that the title here is Your Java Journey into the Serverless World. And my slide says Serverless and Serviceful, where microservices complement serverless. So it's the same talk with two different titles, because what we will see today together is that the journey that us developers will do to adopt serverless. And it's not serverless for serverless itself, for just a matter of technology. We need to see how serverless will complement microservices, and also it's all about services in general, okay? So let's start our talk today. Usually people ask me, what about these slides? So these slides are already available. You can go to this link, bit.ly/serverlessful, and we'll talk more about why serverlessful during this talk. My name is Rafael Benedives. I work for Red Hat as a Director of Developer Experience. It's my first time here in Turkey, so I'm very, very happy to be here. By the way, essentially, I'm also a Java developer. So it's good to be in a Java conference, okay? What you will see here was part of the keynote, the Red Hat keynote in 2018, last year in Boston. So it's really a really cool topic. By the way, before starting talking related to serverless, I'd like to invite everyone here to be part of the Red Hat Developers Program, where you can go to this website and have access to free resources for our developers, like free ebooks, free webinars, blog posts. So, for example, you can get microservices for Java developers, building reactive microservice in Java from Clement. Clement was here this morning, and there will be a workshop this afternoon. It's happening now, in fact. Migrating microservice to microservice database from Edson Yanaga. Edson Yanaga was here on the last Java Day Istanbul. Introduction Istio Service Mesh for microservices. By the way, at 4 o'clock, I'll give a workshop about Istio, so everyone is invited. And since we are in a Java conference, I need to talk to you about microprofile. Have you heard about microprofile? It's a specification to build microservices. And also, like last week, Red Hat announced Quarkus.io. Quarkus is really nice. It's a really nice technology, especially to create lightweight containers. Let me just give you a hint on how Quarkus works. So I will create here a project from the scratch using Maven. By the way, I think that there's no sound out here. Can you hear me well? Okay, as I said, usually because I talk too loud. So I just created a project using Quarkus. It's in this folder called Getting Started. So I can do a Maven package here. So I just want to show you how it's really, really fast. Of course, there are tests involved. And now I'll have a jar file that I can execute here with, let me just increase the font, java-jar, getting started, and here, it was started in less than 1 second. Let me just open the page. It's a Java application working. If you take a look here on the active console, the activity console, you can see that it uses just a tiny amount of memory. So it's amazing. You should take a look. Just go to this website, quarkus.io, and you'll be amazed about this technology. Okay, by the way, I brought to you Chromebook to raffle, and here are some rules to get. At the end of the session, I will run an application that will look for everyone who followed me on Twitter. These are the rules. Took a picture of the session mentioning something nice about the session. I hope
Java Day Istanbul. Then my application will get all those tweeters and perform the raffle. Okay? By the way, let me just take a picture of you as well, so I can post a picture of you in my Twitter. Okay? So let's do a selfie, a selfie together. So, say hi everyone. Hi. Ooh, perfect. Okay. Let me keep my clock here so I can know how long we have. Okay. I don't know if you know this guy here, Thor, but there's a movie where he said, our ancestors called it magic, but you call it computer science. I come from a land where they are one and the same. Because essentially what we will see here looks like magic, but in fact it's computer science. Okay, before going to monolith, before going to microservice, everyone produced monoliths, right? And of course, there were modules inside it. And then we decided to take those modules, transform those modules in microservices. And of course, they don't live together. We spread those microservices in different services and create a network of services, a service mesh. Of course, each microservice have their own data. They can have multiple points of entry, and we tend to think as developers that everything will be okay, right? We tend to think that the network is always reliable. We tend to think that the latency is always zero, that bandwidth is infinite, the topology doesn't change. There's one administrator, there's no cost. Of course, all of these things are fallacies of distributed computing, right? So, what we want as a developer is that in a case of failure, if there is a failure of one of these microservices, we want to avoid a cascading failure, right? And for that, we added some features inside each microservice, right? So we added service discovery, we added load balancer, because we can have multiple replicas. We added resilience, matrix tracing, and let's just recap a short history of microservices. We saw that there was a movement of the Agile Manifesto, Agile Praxis. Then the cloud was born in 2006 with Amazon. Then there was the DevOps, Java 6 was released in 2009. Then, finally, Netflix was released and became open source with the projects Histrix, Ribbon, Eureka. Then finally Microservice was assets by its ThoughtWorks Radar, Docker and containers was released in 2013. Then came Spring Boot. Microservice was defined, and Kubernetes was released in 2014. So here you can see, not very well, but in red, that everything related to microservice came with Netflix. So Netflix was the big motivator of adopting and creating microservices. But there is a problem with Netflix OSS. It only works for Java application. I know that everyone here uses Java. Is there other language besides Java that you use? Is there Node.js, Python, Go, PHP? Yeah, so the problem with Netflix OSS, as I said, is because it's based on Java. And if you are producing microservices using different languages than Java, you probably need library in Python, in Go, in Node that performs the same things, that can perform service discovery, resilience, load balancer, right? Because no matter what language you are using, no matter if you are using Node, no matter if you are using Go or Spring, there are certain properties that every microservice needs to have. The first one is the API, right? Every microservice needs to have its own clear API. Then we need a discovery mechanism, right? We need a way to find that microservice. Then we need a way to invoke that microservice. Is it REST? Is it messaging? Like QP? We need elasticity because the demand on a microservice can grow or shrink. So we need elasticity. We need resilience because a microservice cannot fail. It will fail for sure. So we need to be prepared. We need the resilience. We need a way to get that source code from the Git repo to the production. So we need a pipeline. We need authentication. Most microservices need authentication. We need logging, a way to collect the logs from different microservices. We don't have just a single monolith. So we need a way to collect, aggregate all those logins. We need monitoring. We need tracing, again, because we don't have just a single stack trace. It's spread across the network. So all those things needs to be part of our microservice, no matter what language you are using. But fortunately, we can have those things for free when we use platforms like Kubernetes or OpenShift. Because, for example, when you use Kubernetes, you have discovery, invocation, and elasticity for free. Then, when you use monitoring, logging, and pipeline, you have, when you use OpenShift, you have monitoring, logging, and pipeline for free. Now I want to talk to you about Istio. Because, let me just open here an example about Istio. Learn OpenShift, search mesh. By the way, just recapping, I will give a workshop about Istio 4 o'clock. Let me just keep it installed in some microservices here. And a search mesh is when you have a proxy just beside your application, and this proxy will handle all the communication between the microservices. So with Istio, you will have a smart discovery, you will have a better resilience, you will have authentication, you will have also monitoring, and you will have tracing. So you, as a developer, just need to care about the API. So when you adopt Kubernetes, OpenShift, and Istio, you don't need to concern about all those things. And again, no matter if you are using Java, with Spring Boot, Node.js, Python, Go, no matter what language you are using. So before Istio, we are Java developers, we used Netflix OSS inside our services. Now after Istio, all those features are now part of the sidecar container. So the sidecar container intercepts all the traffic and allows you to perform certain features like circuit breaker, retry policies, smart routing. So this is a sidecar container. So with Istio, you can perform chaos injection, as I said, circuit breaker. Let me just give you an example of Istio implementation here. What I will do now, I have 3 microservices. I have one microservice called customer recommendation, customer preference and recommendation, A, B, and C. One is using Vertex, as you can see here, it's already installing. And I will use Istio and send every traffic, 100% of the traffic to the version V1. So as you can see here, I have V1, and in a couple of moments we'll have V2 also. Just double check here. V2 replying. When I apply this rule, you can see here, let me apply. Now only V1 replies, okay? And if I can use this other rule here and say if the user agent in the HTTP header, the user agent has Safari, I can send the traffic to version 2. Otherwise, send the traffic to version 1. So let me apply this rule, and then I can, for example, simulate that with Chrome. Oops. If the agent here has Safari, I will see V2. So I can click that several times, I won't see V2. If the user agent is anything else, like Firefox, I will see V1. This is just a simple example of Istio and Service Mesh, but I will not spend a lot of time here because we have 2 hours later just about Istio, and let's now focus on everything else. Because, as Spock said, change is the essential process of all existence. So, let there be functions. Let's talk about the functions. We are here to talk about serverless. So, when we were producing microservices, everything is on your hands. You control the deployment of microservices. You control the server. It's a well-known process. Usually, it's a long-lived process, right? It's a non-programming model. Usually, it's for a synchronous request, and it's most of the time major, right? You have integration with IDE, debuggers, tracers, monitoring. That's easy. But now in the serverless world, it's totally different. You don't have the control. It's the cloud who controls the execution of your code. And because of that, you don't usually have a long-lived process. It's just for a tiny process. It's for a short-lived process. Of course, it involves a new programming model. Although we can use Java, we will use Java in a functional approach. You will try to produce more functions instead of methods. Usually, it's based on an event-driven architecture. The maturity, it depends. Some cloud providers they are more mature, others are just starting. So it's a question mark here. There are different levels of maturity when we are talking about serverless and functions. Usually, it's called serverless because you don't control. We don't think about managing the server. We don't install a server. We don't put our code deployed on an application server. Usually, it's controlled by cloud. But in fact, there are services involved. When you deploy a function in a serverless engine, there will be a server that will start your function, execute it, and just remove the resources. So it's not a good name, I know, but it has this name because the server is not always on. Okay? But before starting producing functions, we need to ask ourselves, is there a simple service I can consume before? Is there something that I can buy or set up using a cloud provider? So that's the point. Nowadays, that's why this session is called serverless, and serviceful, because it's all about services. For example, is there anything that you can buy from Google, from Amazon, from Microsoft, Azure? Is there, for example, an HTTP input and output service that you can buy and have an API gateway as a service? Is there a single sign-on that you can buy as a service? Is there a storage that you can buy as a service? Cache, database? Probably you don't need to build or host one. You can buy it then. Then you can use or buy connectivity services like messaging and notifications. Then, if you can buy those things, you can place your microservices there and just take care about the business logic. All the other things are provided by the cloud providers. And finally, you can use functions to tie those things together in an event-driven input and also output. So that's the purpose, that's one of the reasons that you will adopt functions. Okay? And that will create a synergy for your application. Things that you can buy, things that you build, and functions to glue all those things. Okay? So you can see that as far that you go to the right-hand side, less you need to take care about infrastructure. Because when you have things on-premise, you need to take care about server, storage, network, operational system, the runtime, the data, the application, and finally the business logic. When you go to a function as a service, you just care about the business logic itself. All the other things are managed by someone else, usually the cloud provider. So when we talk about the functions as a service, there are different Kubernetes players. There is the project Kubeless, the FN project, Fusion, OpenFast, Griff. There's also Knative, that's still on the version 0.4 if I'm not wrong. I think, yeah, 0.4 was released some days ago. But we would focus on a demo related to Apache OpenWhisk. Why? Because Apache OpenWhisk works with Kubernetes, with Docker, with containers, and has support for different languages. You can write functions using JavaScript, Swift, Java, Python, PHP, Docker, Go. So that's good. So let's take a look here. Is there any JavaScript developer? So I guess that it will be familiar to you if you see a code like this. A function that will receive parameters, and then I'll get the one parameter called body and write on the log. JavaScript on OpenWhisk on OpenShift. Before showing this function here, let me just show how OpenWhisk works. To interact with OpenWhisk, I have a WSK command that I can do, for example, WSK action list to list all my actions. I can explore existing functions, for example. You can see that most functions here are using Node.js, but we'll talk about Java also, okay? We are in a Java conference. But let's explore this function here. So WSK action get and the name of the action. That will give me an output with some information. I can see here that it's a Node.js. The sample output is here. Hello cat for Naudasburg. I can inform some parameters like the name, it's not required, the place, and has some limits for the container. So let me invoke here this function. WSK to invoke an action, WSK action invoke, the name of the action, and I will ask for the result. Okay? So, hello, stranger from somewhere. If I want to use a parameter, I can use the parameter. I saw here that the parameter can be name and place. So let's use name, Rafael, and parameter place is Istanbul. Okay? Now I have here, hello, Rafael from Istanbul. Very simple, very easy to use. But let's return to our message action JavaScript. Okay? Now I want to turn this code in an action that I can invoke. So I'll use WSK action create, the name of the action, message action, and the file, message action JS. Now I have an action I can invoke again. I can invoke it using WSK action invoke, message action, Python developer here? Oh, we have a Python developer. So if this code here looks very familiar to you, right? So let's take that and let's update this action and use the Python code, for example. Now I can invoke Python on OpenWhisp on OpenShift. You saw that I didn't change anything. It's the same invocation, but I used different language. So that's how I can have a kind of interface and allows me to be event-driven. I can just send event with parameters, and that will give me a result. Of course, I can work asynchronously, because if I remove the result here, it will give me an invocation that I can consume that invocation, that activation, get, and this ID here, I will have the details of this invocation. Python on OpenWhisp on OpenShift. So I can perform several invocations here, and every time I will have a different identification for that invocation, right? Okay, but let's continue. Go. JavaScript. Okay, Python. And what about Java? Java is a little bit more complex, right? Because we cannot just give a Java file. We need to give a jar, a class. So the project for Java is a little bit different. So the OpenWhisp project allows you to install a Maven archetype that you can use to generate a project. So let me use this Java archetype here and create a project here from the scratch at this moment. Let's create a project. And cross our fingers. I'm doing a live demo. So let's go to this action Java, right? And now I can perform a package. So I'll have a jar file. And now to turn that in an action, I will update the message action. I will give now the name of the jar file and the parameter main with the name of my main class. Okay, so this is the name of the main class. Now I can invoke. I'll just use the same message action again. Oops. Dash result. Hello, welcome to OpenWhisp. And look here. This is a Java application. Look how fast it is to give me a result. Oops. Yeah. So it's really fast, although it's Java, it's very fast. And you can see how it works on the cluster side. I'm running OpenWhisp inside OpenShift. So all of these are containers. So let me get here all the containers that status is active. Okay, let me invoke. You can see that it creates the container. That, of course, it gave me the result. And after some seconds, it's gone. So you don't control. The resource is removed. It will not spend CPU, memory, or disk to give you the invocation. And again, Java, very fast. So let's keep moving. Of course, we can create an add action. So when I created this this function here, I could say web equals true. In that case, if I get the action called message action and get the URL, I can go to this URL.json and that will invoke the function and give me the result. Of course, I can use HTTP post to send also parameters to that function. Okay? So as string in an array. So let's take a text here. Let me get Rafael, Benedives, Istanbul, Java, what else? Java Day. Yeah, that's fine. Let me invoke and record the result in a file called split.json. So you can see, I took a string and this function split it in an array. Now I can invoke that action, an action called sorter, but I can use a parameter file from the previous action and get the result. This action will sort, will alphabetically sort this string. So I can invoke, and now it's sorted. Benedives, Istanbul, Java Day, and Rafael. And of course I can get that action and turn everything in an uppercase using the result from the previous version. It seems hard, right, to invoke every sequence and wait for the result. So what I can do is to create a sequence action. I can create an action that's based on a sequence of the following versions, from the following actions, from the splitter, uppercaser, and sorter. Now, I can invoke that action. So let's give the parameter here, Rafael, Benedives, Java, Istanbul, Java Day. And one single shot, and the result of one sequence of one action was passed as a parameter to another. And here, if we take a look, we saw that it creates the three containers, the uppercaser, sorter, and splitter, and we have the result. Then after some seconds, the resource will be removed. So it's, again, very, very flexible. But let's take a look here on some terms. The actions is what you saw. I performed actions, I invoked actions, right? If I don't ask for the immediately result, it will create an activation that I can get the activation later, activation get, and see the result here. And you can see that in this case, because it's a sequence, I have 3 logs, I have the result, I have the result, right, the activation. I can use create package to group all functions. So WSK package list. So there are some packages here. I've created even a package for my demo, package get. So inside this demo I have the following actions: split, uppercase, and sort, sorter, uppercase, splitter. And now we go more advanced. Feed is to act as an interface between event source and actions. We have triggers, that is a stimulus, and a rule that ties everything together. And so it's more or less this way. We have external service, for example, a messaging. Remember that I said that I can use functions to perform as a glue from different services that you can buy. So you have an external service that will feed the function engine, which will trigger an action based on a rule. So let me show you a really advanced demo here. I have Apache ActiveMQ running. I will use a Node.js application to send a message to ActiveMQ that will trigger a sequence of functions, each one of them written in a different language. So it will evoke JavaScript, Go, Java, and Python. And then the result will be published again on ActiveMQ. So I have another Node.js application that will load the result. So let's take a look here. WSK action. properties, parameters that will be used by every function. So, for example, the connection to my Apache AMQP, my Apache Artemis, is here defined as a parameter that will be used by every action. And here are my actions. The message sender is written in Node.js, sorter uses Go, uppercase is written in Java, and the splitter is used in Python. So the first thing that we need to do is to create a sequence, right? A sequence that if I call split sort uppercase, it will call all those actions. The splitter, uppercase, sorter, and the sender. The sender will place the message again on the queue, right? Now I need a trigger, which means that, hold on a second, let me just copy here because it's a long line. So the trigger is based on the feed of AMQP feed. So everything that is posted on Apache Artemis on the Q99, it will cause a trigger. And now we need a rule to tie the action, the action split sort uppercase with the trigger that I just created. I'm just giving the name rule split sort uppercase, right? Now I've tied everything together. I will start here my Node.js demo that's listening the Apache Artemis IP port, and let me specify a queue here. Let me say reply Java. Okay, and now I can use another demo, another Node.js application that will post reply. Will post the following text: Rafael, Benedives, Java, Istanbul, Java Day, and the reply will be sent to reply Java. So let me send this, and the message was accepted. It will call all the functions, and let me see if it's happening here. Yeah, it's called the functions in sequence, and we have the result here. Okay, so this is an advanced demo how we can tie the different things. Okay, now that we have, by the way, before going to the end, let me talk to you about, about cloud events, which is a specification related to cloud native events. It was just released, the version 0.2, so it's really initial, but it will describe event data in a common way. So it's good to know that there is a specification for cloud events. Okay, let me check if there are any questions, and then we'll go to the raffle. Okay, thank you. How to overcome cold start times in serverless architectures, considering cost. So you saw that the cold start was really really small. The amount of time I created actions from the scratch, and it was really fast. So the cost is not really, the cost and the time is not really a problem. Okay. We should manage so many applications to build microservice architecture. That's true. Okay. Perfect. Is it hard to maintain for not that big companies? Yes, it's hard. Microservice, it's hard to deploy. It's hard to maintain. It's hard to manage. The only reason that we are adopting microservice is because of the agility. Some really huge companies, they need to be agile, they need to release code faster, they need to use different technologies. For those cases, it's, the use of microservices is justified. In other cases, just go to their regular, or we can adopt certain certain microservice practices like pipelines, containers, agile practices that will help you, but it's not the, but probably microservice is not for you. So, which is better for serverless considering JVM based and other languages? I would say that my favorite stack at this moment for JVM based serverless application is Knative with Quarkus. Knative and Quarkus, because as I said, Quarkus is really small and fast, so it's a Java application that you can start. It's not just a function, which is different from serverless. With Quarkus, you have a full Java application that you can start in seconds, and Knative will allow you to create a container, execute the request, and just die. So that's my favorite architecture at this moment. Can message brokers cause single point of failure? If so, how can I avoid it? With a cluster? Yeah, it can be, but you will need a cluster of message brokers. What about remote call, login, local debugging? Yeah, of course, it's really hard. It depends of the function as our server engine. Containers can really restrict some actions according to IPs. I don't know specifically in OpenWhisk we can do that, but using Istio you can, because Istio allows you to have access control list. Again, there is a workshop of Istio. How far the capabilities of a function can go? Yeah, can replace any API with Knative. That's the beauty of Knative, because it's not really attached to a specific function. Others are Whisk, reduce code start time. It creates pre-warmed containers. So we have, for example, here pre-warmed Node.js. So let's go to our Rafael. Let's Rafael embed Spring Boot run. And by the way, to win the run book, you need to be in the room, okay? Of course. So, localhost, and the tag is Java day is done. So let's see. Wow, we have a lot of tweeters, enabled users, and the winner is, this is, it's not a lot, Java day is so let me run again, okay?
Yeah, it's me.
It's
It was me, very strong.
Mr. Carlos Khan.
Yes.
Sequence action on Whisk on OpenShift.
Come on.
Congratulations.
Sorry, sorry. First one was my name.
Like Java Day Istanbul?
Yes, no. After Java Day Istanbul, it was me. Like Sıhhaverdi 90.
I'll give you another.
Okay.